6.3, solving compound inequalities, part 2. We did part 1 before spring break, right? So, what do you guys remember about compound inequalities from before spring break?
A compound inequality is two or more inequalities that are connected by the word and or.
Yeah, they're compound because it contains two or more inequalities. The two words that we use to combine them are the words and or the word or. Do you guys remember what we call the graph of an and compound inequality? Starts with an I. It is an intersection. Remember, it's where we wanted the graph, or we wanted the parts of the graph where the graphs were going to be the same from each of my two inequalities. We wanted the intersection, the overlap, where the two shaded regions were the same. Do you remember what the graph of an or compound inequality is called? Starts with a U. Union. Yes, it's a union. It's essentially you're kind of just graphing both graphs on the same graph. Okay? What do we remember about and compound inequalities?
Both of them have to be true.
Yeah, in order for a number to be a solution for an and compound inequality, it must meet both conditions of both of my inequalities at the same time. It's got to be true for both inequalities. What is a number, or how do I know if a number is a solution for an or compound inequality?
Only one of the inequalities has to be
Yeah,
correct.
the number is only true, or it only has to be true for one of my inequalities or the other. It doesn't have to be for both like our and compound inequalities. So, that was just a little quick recap before we get into the last half of 6.3. Example 4 here. Solve 4k plus 12 is less than 2, or 4 minus 2k is greater than 4. Then graph the solution set. Do you guys remember how we solve or compound inequalities?
Yes.
How?
We're going to start by doing minus 12.
Yeah. Do I do minus 12 to both inequalities?
Yes. No.
No, we're just solving them individually, correct? I'm solving 4k plus 12 is less than 2. By itself, I'm solving 4 minus 2k is greater than 4 by itself, keeping the word or between my inequalities. So, like we said, for this first inequality, we'll subtract 12 from both sides, trying to get k by itself. 2 minus 12. Negative 10. Inequality symbol, flip or stay the same?
Stay the same.
Stay the same. Once again, when do inequality symbols flip?
When you divide by multiplying by a negative.
Only when you multiply or divide both sides of the inequality by the same negative number. Okay? Bring your word or down. What am I going to do first on this inequality over here on the right? I'm trying to get k by itself.
Subtract 4.
Subtract 4. That leaves me with negative 2k. What's 4 minus 4?
0.
0. Symbol, flip or stay?
Stay.
Stay. Are we okay with the first step of each inequality here? Questions, comments, concerns there? Okay. First inequality on the left. How would I get k by itself?
Divide by 4.
Divide by 4. Negative 10 divided by 4. Will that give me a whole number?
No.
No, let's go ahead and leave it as a fraction for now. Can I simplify negative 10 over 4?
Yes.
What are negative 10 and 4 both divisible by?
2.
Negative 10 divided by 2.
Negative 5.
Negative 5. 4 divided by 2.
2.
2. Symbol, flip or stay?
Flip. Oh, it's stay.
Stay. We divided by a positive, so it stays the same. Keep that word or between your inequalities. What's my next step on the right inequality to get k by itself?
Divide by negative 2.
Divide both sides by negative 2. 0 divided by negative 2 gives me 0. Symbol, flip or stay? Flip. We divided both sides of this inequality by the same negative number. So I've got to flip from greater than to less than. Are both k's now isolated by themselves on one side of the inequality?
Yes.
Yes, they are. So here is my solution to this compound inequality. K is less than negative 5 halves, or K is less than 0. So there's our solution. Now we need to graph it. If I were to convert negative 5 halves to a decimal, what would that be?
Negative 2.5.
Negative 2.5. Okay, I got my graph drawn up here. This is an OR compound inequality, so what do you think the graph is going to look like? Well, first off, would I have an open or closed circle on negative 5 halves or negative 2.5? Open. I'm going to do it above the graph so we can look at something right now. Negative 2.5 is halfway between negative 2 and 3. Open or closed circle on 0?
Open.
Open. Usually for an OR compound inequality, we graph them both on the same graph. It's usually from the 2 points going outwards. Correct?
Yep.
Let's see if that's the case here. It says K is less than negative 5 halves. Would that be to the left or right of negative 2.5? Left. Or K is less than 0. Left or right of 0?
Left.
Left. This looks a little different than what we saw before spring break, correct?
Yes.
Any ideas what the final graph needs to look like? Thinking about what an OR compound inequality means. What does it mean in order for a number to be a solution of this compound inequality? What does it mean?
Only one of them has to be true.
It only has to be true for one of the inequalities. Okay? So, this K is less than negative 5 halves is encompassed in this graph of K is less than 0, correct? So, if a number is a solution of this one, it means it's automatically a solution of this one as well. Right? So my graph just needs to have the open circle on 0. Just shade it all the way to the left. That'll fit all my conditions. Okay? So, these would not be your graph, but this would be your final graph. Do we understand that? So essentially, my solution really only needs to be K is less than 0. Because K is less than negative 5 halves is already encompassed within that. So it's kind of redundant to write that part as well. Does that make sense? Any questions on this? That's why this example is titled Overlapping Intervals. Because these intervals overlap with each other, which is fine. That can happen sometimes. Like I said before spring break, your graph is not always going to be from your 2 points outwards. That's what it will be most of the time for an OR, but not every single time. Okay? Any questions on that? Okay. Just thinking off the top of my head here, I'm going to create another example real quick. Let's say we had an AND compound inequality, and we got to an answer that looked like x is greater than or equal to 3, and x is greater than or equal to, let's say, 7. Okay? Let's say we got that as our final answer. Okay. Open or close circle on 3.
Closed.
Closed. Once again, I'm going to graph above before I do my final graph. Open or close circle on 7.
Closed.
Closed. Previously, before spring break, all of our and compound inequalities were graphed and shaded between our 2 points, correct? Because that's where the overlap of those 2 graphs were. This is still an and compound inequality. I still want the overlap of the 2 graphs. For x is greater than or equal to 3, would I be shading to the left or right of 3?
Right.
To the right. X is greater than or equal to 7, would that be to the left or right of 7?
To the right.
To the right. Are they being shaded towards each other?
No.
No. So is that overlap going to be between these 2 points now?
No.
No. Where would the overlap of these 2 graphs be? Where would they intersect?
7 and beyond.
Yeah, just 7 and beyond in this case. That's going to be the only numbers that meet both of my criteria at the same time. So this would be my graph of this compound inequality. Do we understand that? So it's not always going to be from your 2 circles in for and. Most of the time it will be, but sometimes it looks a little different. And for or, most of the time it'll be from the 2 points out, but not all the time. We have some scenarios where it's not like that. Okay? Do we understand that?
Yes, sir.
Questions, comments, concerns? Okay. Example 5. I got this example and then one more and then I'm done. 2 more examples here. Write a compound inequality that describes the graph. Earlier, we were solving for an inequality and then graphing it. Now we're kind of working backwards. We're given the graph and it wants us to create a compound inequality to describe this graph. Okay? So, does it give us a specific variable to use? So we can pick whatever variable we want. Raise your hand if you'd like to pick our variable for me.
I never get paid lunch.
What?
Just W.
W. Okay, we'll use W. We're just going to build this based on the types of circles we have, where the shaded region is, and everything like that. Right off the bat, is this going to be and or? And. It's the intersection of 2 graphs. It's just the overlap of 2 graphs. So I'm going to go ahead and write the word and for us. Now let's talk about this -2 here. We said W. The circle is on -2, so I know that's going to be part of my inequality. Is the shaded region to the left or right of -2?
Left. No, it's right.
To the right.
To the right.
I'm forgetting because it's like
So would that be numbers that are less than or greater than -2?
greater than.
Greater than? Open or close circle?
Close.
Open. So line or no line?
No, no,
What?
no.
No line. Are we okay with how we got W is greater than -2?
Yeah.
You okay with that?
Say close. You can do this.
We okay with that? Okay. Now let's build the other one. We're going to have W. What's the other number that has a circle on it?
4.
4. Is the shading to the left or to the right of 4?
To the left.
Left. So would that be less than or greater than 4?
Less than or equal to.
Less than. Open or close circle?
Closed.
Close.
Close. So line or no line?
Line.
Line. And you could keep this as your answer. Everyone okay with how we got that?
Yeah.
Now, the computer may not like it like this. How might the computer like it?
In like the correct form.
In that special way that we write it, yeah. Do you remember? How would I write this in that special way?
The 3 line W, then do that, and then do the line.
What would come first in my big inequality here? What's the smaller of the 2 numbers?
Negative.
-2.
-2. What's the relationship between -2 and W? Reading it from -2's perspective. Is it less than? Is it greater than? Is it? Well, it says W is greater than -2. So that would make -2 less than W. What's the relationship between W and 4? Less than or equal to.
Got it.
This would be the special way to write it.
Got it.
Remember, you can only write and compound inequalities like this. Okay? Or compound inequalities have to have the word or between them. Any questions or confusion how I got this for example 5? Can I move on?
Yes.
Last example. Write a compound inequality that describes the graph. Right off the bat, is this and or? Or. If it's from the 2 points out, it's automatically going to be an or. That's the union of the two graphs. Raise your hand if you'd like to pick the variable for me.
Give me J.
J. We'll use J. So I've got J. What's the first number that has a circle on it? 8. Are we shading to the left or right of 8 from this point?
Left.
Left, would that be less than or greater than?
Left.
Less than, open or closed circle?
Close.
Closed, line or no line?
1.
Questions how I got that for my first inequality?
Yes, sir.
Are we okay with building that?
Yes.
Okay. We got J again. What number am I using here?
12.
12. It's the other number that has the circle on it. It's shaded to the right of 12, so that would be
Greater than.
No.
greater than, open or closed circle,
Open.
open, line or no line?
No line.
No line. Is this my final answer?
Yes, sir.
Yes, it is. Questions how I got that?
None.
Do those examples seem pretty easy? Building the inequality from the graph,
Yes.
hopefully. If it doesn't give you a specific variable, pick your own variable. If it tells you to use a specific variable, you've got to use that variable. Remember, the computer's picky. If it gives you a capital, you got to use capital. If it gives you lowercase, you got to use lowercase. Okay? First off, figure out if it's and or based on the shading. If it's between the 2 points, it's going to be and. If it's from the 2 points out, it's going to be or. Use your variable. Whatever the number the points are on, the circles, those are going to be the numbers that you use within your inequality. And then you get your inequality symbols based on the shading and the type of circle. Okay? Any questions on example 6? How are we feeling about this?
Feeling good.
Very good.
Good.
Confident.
Here's your assignment. I've got to get it published for you on Canvas real quick. You should be able to go ahead and get to it through McGraw-Hill if you beat me to getting to my computer. Do we have any questions about the notes before I end my recording?
None. I got a different question.